And we have grouped this into two exercise sessions. The first session that we are entering now is a session introductory, telling you or showing us all how to set up a matrix that represents a graph. So to remind you, a matrix is an object within MATLAB that MATLAB can manipulate conveniently. And actually the MAT in MATLAB stands for matrix. It's a matrix laboratory, so to speak. So if we want to manipulate networks, the first thing we do is to set up a matrix that contains network information in a meaningful way. If you have worked through the materials to this session, you know that we do this by setting up a matrix with zeros and ones, where zeros mean no connection and one means a connection. So what do we have? Let's look at this command that I have taken similarly as it's in the materials. So my matrix is a new matrix that I'm going to create, again as before, by clicking run a section of the MATLAB code. And running this specific matrix that you see on your screen, we'll see in the left side on the command window, we see the entries to the matrix in terms of zeros and 1 as a squared or as a rectangle that has dimensions 5 by 5. So we have 5 rows and 5 columns. First row, first column is an entry which is 0, which means the first element is not connected to itself. Second row but first column is an entry 1, which means the second element is connected to the first element. So the second element, second row, is connected to the first element, represented by the first column, and so on. You can count down these 1, 2, 3, 4, 5. Obviously, in the first row, you continue counting in the second column, which is then number 6 here, to 7, 8, 9, 10, and so on. And last but one, the entry 1 would be number 24, connection 24. And the last would be number 25, no connection of element 5 to itself. This is our matrix. First thing we want to do with this matrix is to ask, is this the only way to set it up, or are there alternative ways? And I have only shown you here in the second section of the code one alternative way to set up a matrix. And this way is particularly useful if you have a large matrix where most of the entries are zeros, because it uses a function called zeros that will set up the matrix with the correct dimensions, so 5 by 5 here, but putting a 0 in all the places. And then by hand you later put in ones in the places where ones are supposed to be. You can use this exercise to remind you and to practice what you have learned in the first session of this course, namely to use MATLAB code to access individual elements of a vector or matrix. I don't go into the details here, but I'm going to execute this code for you to show what happens if I do so. Well, incidentally, it produces exactly the same matrix as before. As I said, it's just an alternative way of setting it up. And you can see there are advantages. Sometimes, if the matrix is small enough, you might just do it as it's done in the first way. But sometimes it's much easier to do it in the second way. If you have a very large matrix, that will be more convenient. If you want, the first section here is just an exercise for you to practice. It asks you to set up a matrix that starts with all ones. Meaning, if you have a large matrix where many connections between nodes are found, so there are many ones, it's easier to start up with a matrix where all are ones and then only manually change those that are 0 by hand. But I leave that for you. We don't do that now. You can check it and do it later for practice. Now that we have our matrix, we need to look into matrix features. We want to know, is my matrix set up correctly? So one thing we want to know, how many nodes are in this network represented by this very matrix that we just have created. So this piece of code here initially has a command called CLC, which just means clear my window, clear my command window. The second line is to just display the matrix that we have presently, and the 2 lines at the bottom of the code then help you to count the nodes and display the number of the result of this count by using a function called size. Now, if our matrix, which is called my matrix, is an argument of that function, you can actually execute this, and you can find out on the left side in the control panel, it says that our matrix here has 5 nodes, which you know, of course, because it's a 5 by 5 matrix. The number of rows and the number of columns is identical to the number of nodes in your network. Right, so having done this, we now also want to count the edges which are there. How many edges do we have? Here's a piece of code which is slightly more complicated. It uses a command called find, a function called find, to check whether there are ones in your matrix. So it says, where in my matrix, called my matrix, is an element that has the value of 1? And then these are counted by using the function length. So if I execute this code all together, what we first get is the indices, where in the matrix are the connections located, and then we count them, and we find here the answer is the number of edges is 9. There are 9 connections specified in this matrix that we have set up manually at the beginning. It's shown at the top of the command window. If you want to check, just count the number of edges, and it will indeed be 9. So now we know these features, number of nodes and number of edges, and we can check whether we've done everything correctly. For your practice, there's another example as a code given that you can take a look at later on. I don't go through this, but it's actually one of the exercises that you're supposed to do when you go through the PDF materials. So here's a code that helps you to do this. You can either copy and paste or write your own code as you wish. And it will just give you a similar result as the one that we have just created now. All right, let's have a final point in this context here. We don't do any more analytics on the network, but what we want to do, what if you want to use this matrix that we have now defined nicely with ones and zeros in a common way? What if you want to use that information in another software? You need to save this information and put it in a file in your laptop or desktop. So I have shown you at the bottom, here's a command that says how to do saving content of your MATLAB environment. And if I execute this, if I run this section here, you can see on the right side of the screen, running this command has immediately created a file which contains all the matrix information organized in columns and rows in a plain text file. So you can then use it, for example, for Cytoscape. You can incorporate it and work there in different environments as well. Yep. That finishes this exercise. I hope you were able to follow me. Remember that our chat box is open, and both Nadine and Charlie are busy looking at your chat comments and trying to answer as possible individually, or make a note for me to pick your questions up later in the chat session at the end of today's session. Right, I've closed this window. I clear my command window, and we can now go to our main MATLAB exercise, namely to look at MATLAB code that helps you create your assignment number 2, your network assignment number 2, that you're asked to upload to the Moodle website. So it asks you to create a matrix. So we don't do that soil biota matrix that you are asked to do in the code, but something similar. We just use the matrix that we have worked with already. And for convenience, I have put them again into the same code. So without much comment, I do run this section, and we can see on the command window that we actually can create the same matrix again.